Hello, linear algebra student. This video is for chapter 1.9, the last video, part 4. We're still on to proving if a linear transformation is onto or one-to-one. So let's review the theorem. The last theorem that we have would be we know if it's a linear transformation and we have a matrix, we know the transformation is a onto if the column actually span out M. So that means you do not have any free, so all of your columns are prefix column. So basically what it is. And then you can check one-to-one if you can actually have only one solution for AX equal to 0, or the columns are linear independent. So just remember that. So let's look at, or there's no free columns. So one is about row, one is about column. So let's do the third example. So my T of x1, x2, x3 is this. I'm going to write a standard matrix. So if I am to write it down, so it would be x1, x2, x3 is my input. And the matrix that I would do would be, it become x1 minus x2 plus x3 for the first one. And then, actually become just a 2-entry or R2 matrix. And then what, x2 minus 2x3. So you can see that A would equal to what? For x1, I have 1 and 0. Right? For x2, I can factor out -1 and 1. For x3, I can factor out x3 and we'll have 1 and -2. Right? So this is our standard matrix. Basically look at x1, x2, and x3 and write the column vector, because that's the definition of multiplication of a matrix in a vertical column. And then what do I transfer? So this would be, my input is x1, x2, x3, just like what they specify. So my A must be 3. And what is my B? B is 2 because my columns are actually just our 2 columns. Determine if T is 1-to-1. So 1-to-1 means the columns are independent. So the column must not be, so it is the columns of A are independent if they're 1-to-1, but it is not, right? Because are not. How do I know? Because there's number of columns is more than the row, not independent. You cannot have that because 3 columns, we have 3 vectors is greater than 2 rows. Okay, so 2 of them, if they're not the multiple of each other, they are independent, but then if you have the third one, you cannot be. So they are not 1-to-1. So that means if you solve AX equal to B, sum X, sum B will have two solutions. So this is the definition of 1-to-1. What about onto? Onto means they can map all the X B, right? So and then for onto, what do we say? We look at row, right? So we have to actually do the row echelon form of this. So maybe it is because we only have 2 rows. So if every row is prefix column, then we prefix row, then we are okay. So do a reduced row echelon form. Okay, 1 0 -1 0 here. This one. I didn't enter it yet. So one more column. 1 0 -1 0 1 0 -1 -1 1 and then 1 -2 -1 1 and then -1 what 1 -2 1 and then -2, and do a reduced row check echelon of B, and you can see that we have two prefix column and two, so all the row has 1, 1, 0, -1, 0, 1, -2. That means there's a prefix row, so all rows have prefix position. So you must be able to generate the whole thing. So it is onto. So in a nutshell, that's what you need to know. For onto, you just look at, see if all the prefix row, because onto basically look at if you have ax equal to b is solvable. So long as all the rows are okay, then you should have solution. One-to-one, you look at if they are independent. So independent means if there's no free variables, right? So and in this case, you have three columns and there must be some free variables. So yeah, so that's all for 1.9. The most important thing is if someone gives you a linear transformation, you are able to find the standard matrix, and also based on the standard matrix, look at if this is a one-to-one mapping or onto mapping using theorem 12 and 11 together with theorem 4. Okay, so remember, review all your theorem.